Kirkwood School District video on graphing for 6th grade science. Today we're going to take a look at how students can communicate data using graphs. When you do an experiment, you try to make sense of the data that come from that experiment, and the first step is to organize that data so that way you can understand your results. Data tables and graphs are helpful tools for organizing that data. You can create a data table to record your observations and measurements in an orderly fashion. Typically, when you're doing an experiment, there are two different kinds of variables. There's what's called the independent or manipulated variable. That's the factor that you as the experimenter, as the scientist, are changing. Okay? Now, the dependent variable or the responding variable, that is the thing that changes, or the factor that changes as a result from whatever experiment you're doing. Okay, so for example, if I do more homework, then I'm going to get higher grades. I control how much homework I do. The grades are a result of how much homework. So I myself doing the homework is the independent variable. The grades I receive would be the responding or the dependent variable, because the grades depend on the actions that I do. You record data by using a data table, ensuring to document the numbers, document labels, and then make sure that your whole data table is neat and organized. For example, this is a great data table where you see that you've got columns and rows set up. There's a differentiation between each row in regards to the shading. You've got numbers that all have labels, that things all sort of make sense. There's even some colors and some bolding here. Okay, now this is another data table, a little bit less clear as to what they're trying to do, and they're heating crystals, and there's some numbers, but I'm not really sure what any of the numbers mean, and why are some of them red and some of them blue. There's a little less information here. Now take a look at this data table. Now this one is the most amazing data table. This tells you everything with complete and total clarity. And this is just simply a data table about what kind of different screws or bolts are available at Home Depot or Lowe's or any of the hardware stores. Okay? And this is a really easy data table that you can organize your information to have and to show. So all data tables should have these 5 things. Okay? Number 1, needs a title. Tell me what that data table is about. 2, headings for columns and rows. What do these numbers mean? There's units. So if I've got a number, I can label either the column or the row. What does that number mean? You've got the numbers there, and you've got a grid in some way, shape, or form that shows exactly what number goes with what column or what row. A graph is any diagram that tells how 2 variables or factors that change are related. So you can imagine taking the data that you got from an experiment or a scenario and actually communicating it visually. That would be what a graph is and how a graph works. Now, a graph always has at least 2 axes. Okay? There are 2 lines. One line is horizontal and one line is vertical. The horizontal is called the x-axis. The vertical line is called the y-axis. On the x-axis, you will always find the independent variable. That's the one that I control. So the amount of homework, for example, in our initial scenario, the amount of homework that I do would be across the bottom axis, or the x-axis. Okay? On the y-axis would be the relationship of the dependent variable, the one that changes based on what I did. It responds, or it depends on the amount of homework that I do. Every axis should have the name, the unit of measure, and a range of values equally spaced out. And this is the hardest thing for students. That point right there, a range of values. Typically, students just randomly write down numbers and do not set down a range that are equally spaced out. There are 3 types of graphs we're going to look at in this video. There are many other types of graphs. In science, we typically focus on 3. Bar, pie, and line. A bar graph is a graph that shows data related to counting an amount of a category. It's used to communicate a quantitative number versus a qualitative category or description. So for example, you have up here at the top, you've got factory A, B, and C. Those are those different categories and how many defective cars they had. Now take a look. You've got 0, 5, 10, 15, 20, evenly spaced out with little marks in between, showing exactly what those evenly spaced out numbers are. Okay? A bar graph could also go in this direction, where you have the categories here on the y-axis, and you've got along the x-axis here, you've got the number of students. The number of students depends on the category or color of hair. So there were 4 students that had blonde hair, 6 students that had brown hair, and so forth. We could also use a pie chart, and that is used for fractions or percents. It is also used to communicate the parts of a whole, a percentage or a fraction. So for example, U.S. smartphone market share. This is Steve Jobs, and you can see that previously RIM, Research in Motion, held 39% of the smartphone market share. So of all the smartphones in the world, 39% were made by the company RIM. Okay? This is also another pie chart is based on pie. Pie I have eaten, pie I have not yet eaten. Huh. That's funny. It's a pie chart about pie. That's good. All right. You could also have a line graph. A line graph typically shows a behavior over time, but it doesn't have to. It can be a graph used to communicate how one variable impacts, affects, or depends on another variable. Okay? As you can see, you've got the temperatures in New York City. You've got a title, you've got degrees in Fahrenheit, you've got a label and a unit, you've got the day, so day 1, 2, 3, 4, 5, evenly spaced out, 0, 20, 40, 60, 80, evenly spaced out, and we see the temperature ranges as it goes across. So we can see as the days go on, there's a relationship, the temperature increases. The value of Sarah's car, we can see the line graph going down, and we see that over time, Sarah's car is valued less and less. All graphs in all these different examples you have seen have these 6 things. They all have a title. They all have a labeled x-axis and y-axis with units. They have a 0, which is the origin. They have a consistent gradient. That is the point that students struggle with the most. They have a consistent gradient on each axis, so which means it's counting by a certain number along each axis. And there may be a legend or a key. So here's a sample. You've got a label across the bottom, a label across the side. We have 0, 1, 2, 3, 4, 5. We have 0, 2, 4, 6, 8, 10. We can see that everything's spaced out. There's a title and everything is well organized for that graph. Now, there are great resources available online to help you. This website, createagraph.com, will help you organize your data and make a beautiful graph. Use that as practice. Make up some data, make some graphs, and practice. Okay? We'll be using this website as well as many more to learn about how to create a graph. In this video, we're hoping that you understand now how you can take the data from your science experiment, put it into a data table, and then take that data in that data table and transform it into an awesome graph. Thanks so much. We'll see you soon.